Thank you very much. So I won't be using any slides because what I'm going to talk about showing on slides is not going to be as interesting as anything you see anyway. But as such great progress have been made, as you heard, on those immersive computing and AR, VR-based, and many other embedded AI-based applications. For example, smart manufacturing, autonomous driving, and all of that. It's also time for us to think about how do you best support it? What computing and communication models and paradigms will be needed? For example, one thing has become very clear, that is the current computing model, where you compute either far away in the cloud, or you set up your own proprietary thing or isolated thing in the local places to do computing, are not going to be adequate anymore. And they are not going to be scalable enough, they're not going to be cost effective enough, they're not going to be able to support many of your needs. For example, with all the AR and VR-based applications, you're going to see a lot more data going to be created at the edge in the local places. I would call it big data at the edge. Those data needs to be processed right there, and you can't be shifting them, shipping them somewhere else. And understanding needs to be derived from it. Control based on those analysis needs to be applied right away. And you can't do it all in the cloud. So today, for example, you could set up a server, do it locally, but that means a lot of cost. That means very hard to scale. That also means very hard to integrate with other things that you need to integrate with, for example, cloud capabilities. And to support a lot of those applications, you not only need the real-time data, but very often you need the capabilities that are provided today by the cloud. They have more data, they have historical understanding, they have a bigger perspective that the local devices don't have. And so you need to integrate all of those to provide to the future, to meet the future needs. So then the question is, what should you do? And there is actually, for the past several years, a growing effort to consider how do you fill those gaps, for example, by being able to move computing seamlessly away out of the cloud to anywhere you want, along that continuum from the cloud all the way to your things. And in a very dynamic and also easy to use, secure way, and make it also in a way that you can manage that whole system when you distribute it out to so many places and so on. So that is what we call fog computing. So a lot of progress has been made there as well, and there is an industry consortium, industry and academia consortium called Open Fog Consortium being formulated about 2 years ago. Lots of interest from both the industry and academia because what actually is happening is that this is very much like 10-15 years ago relative to cloud computing. At that time, cloud computing was right at the time now to solve another problem, that is the need for large-scale, supporting large-scale computing and the need to really sort of summarize the computing somewhere else so that you take away the burden of computing from a lot of other users. And now, you need that computing capability to be given back to a lot of the users in a distributed manner to support a lot of the applications you have seen. And how best to do that is the question now. So that is what this future sort of emerging technology fog is supposed to answer. And of course, there are other technologies and paradigm shifts being considered. So I'll stop there. Thank you very much.
Panasonic.